Okay, indicial equations. Let's just go with 3 to the x equals 9. X is 2. We know x is 2, but we need to justify our working. 9 can be represented as 3 squared. So you can see that if the 3's are the same, therefore the x and the 2 must be the same. X equals 2. So it's just about that justifying line. How about 3 to the 2x plus 1 equals 27? We want to represent 27 as a power of 3. Then we go, therefore, 2x plus 1 equals 3. And x equals 1. So it's just about that extra line. 2 to the x plus 1 equals 5. 2 to the x equals 4. Therefore, x equals 2. So we've got to justify how we're doing our working. Sorry, but I've only got 2 pages here. So I'm just going to need to delete the easy ones out. Oh my gosh, we've got more. And a clean slate. Let's get on to something a little bit harder. How about 3 to the x times 3 to the 2x plus 1 equals 81. Clearly we need a base of 3. 3 3s are 9, 3 9s are 27, 3 27s are 81, so that's 3 to the 4. And we need a single 3 over here. We're multiplying like bases, so we add powers. What's x plus 2x plus 1? Once we get to this stage, because our bases are the same, we can go therefore 3x equals 3, x equals 1. So it's not really all that hard. We're just getting like bases and getting an answer. How about 25 to the x divided by 5 to the x? Clearly we're going to get to 5. So 25 is 5 squared. What's 625? 5 5s are 25. 3, I think that's 4. So on this side, when we divide like bases, we subtract. What's 2x minus x? Therefore, x equals 4. Doesn't really, it's not really all that hard. This is the hardest one on the Indicial Equations worksheet. Let's go 3 to the x plus 1 times... Gosh, stop doing that. Okay, 3 to the x plus 1. That's 3 squared, so that'll be 2x. 81 to the x, well 81 is 3. 3 3s are 9, 3 9s are 27, so that's a 4 to the x. But let's just multiply that and go. We are multiplying like bases, so we add the powers. X plus 1 plus 2x is 3x plus 1. So therefore we go clearly. And x equals 1. So not really all that hard. Get into some practice.